In this video, we'll be taking a look at exam-style questions aimed at GCSE higher tier maths for AQA, OCR, Edexcel, WJEC, IGCSE and CIE examples. So it's appropriate for students doing higher tier, and some questions might also be appropriate for students studying foundation, but I'll go through that as we do the questions, guys. This is question number 1. Factorize and solve this quadratic. X squared minus 2x minus 3 equals 0. So double brackets, guys. Okay. Double brackets equals 0. The first step is to put x and x, because x times x is x squared. Okay, I want two numbers that add to give me negative 2 and multiply to give me negative 3. So it's negative 3 and then positive 1. Okay, or positive 1 and negative 3. Either way is fine. The final step now is solving this equation. So either x minus 3 equals 0 or x plus 1 equals 0. So the solutions are x is equal to 3 or x is equal to negative 1. So they are my solutions to the quadratic equations. Remember that if you have x squared in an equation, you are always going to have two distinct real roots unless it's stated otherwise. Okay, so unless the discriminant is negative, in that case there is no solution. But when you factorize a quadratic, you will always have two different distinct solutions. This is question number 2, guys. Factorize and solve x squared minus 5x minus 6 is 0. So again, guys, double brackets because we've got 3 terms. Okay, set it equal to 0. Okay, x and x going off first and second bracket. I want two numbers that add to give me minus 5 and multiply to give me negative 6. Okay, so that's going to be negative 6 and plus 1, because if I expand it, I get x squared plus 1x minus 6x, which is minus 5x, and then minus 6 times positive 1 is negative 6. So solving this, we're going to get that x is equal to 6 or x is equal to negative 1. Okay, so they are my solutions to the quadratic equation, okay, for question number 2. And for question 1 and 2, guys, these can appear on both a higher and a foundation paper. So as we go through, I'm going to be explicit and clear on which questions are higher only and which questions are the crossover, okay. But factorizing quadratics and solving quadratics is part of both foundation and higher. So I've seen those appear on foundation and higher tier for AQA, Edexcel and OCR, and also the other examples as well. Question number 3, expressing completed square form x squared plus 6x plus 20. So completing the square, so it's x plus half of the coefficient of x, so half of 6 is 3, so x plus 3 all squared minus the square of 3, so minus 9 plus 20. Okay, tidying that up a bit, so simplifying it, I get x plus 3 all squared plus 11, guys. Okay, minus 9 plus 20 simplifies to positive 11. Okay, and question 3 would explicitly be on higher tier. So completing the square is not on the foundation tier, it's higher tier only. Okay, this is question number 4. Expressing completed square form x squared plus 4x minus 2. So again, it's x plus half of the coefficient of x, so half of 4, which is 2 all squared, subtract the square of 2, which is 4 minus 2. Okay, and then just tidying that up, guys, by simplifying it, I get x plus 2 all squared minus 6, okay, and that is now in completed square form. Okay, this is question number 5, guys. Let's just change the colour a bit, okay, for each row. Simplify x over 3 plus x over 2. So this is called algebraic fractions, so it's adding fractions. Okay, so putting it under a common denominator, so 3 times 2 is 6. Okay, so it's going to be out of 6, and my answer is going to be out of 6. Cross multiply, so 2 times x is 2x, 3 times x is 3x, 2x plus 3x is 5x, okay, or I can write it as 5/6 x, okay, or 5x over 6, either is fine. Okay, and question 5 would appear on a higher tier only, okay, and it's looking at simplifying algebraic fractions. Okay, this is question number 6, so simplify this fraction, so writing it under a common denominator of 30, so 5 times 6 is 30, okay, out of 30, okay, 6 times 2x is 12x, 5 times x is 5x, so 12x minus 5x is 7x, okay, and that's my answer for question number 6, guys, okay, and that would also appear on a higher tier only, okay, for algebraic fractions. Question number 7, expand and simplify this bracket involving surds. Root 3 times 2 is 2 root 3, and then root 3 times positive root 3 is positive root 9, which is just 3, okay. So my answer is 2 root 3 plus 3 or 3 plus 2 root 3. Either is correct. Okay, so everything in the bracket is being multiplied by root 3. Okay, and this would also appear on a higher tier only. This is question number 8. Expand and simplify this single bracket involving surds. Root 2 times 5 is 5 root 2. And root 2 times positive root 2 is positive root 4, which is going to give me 2, okay, because the square root of 4 is 2, so it's 5 root 2 plus 2, okay, and that would also appear on a higher tier only. Okay, this is question number 6, guys. Find the gradient of the line 2y minus 4x equals 2. Well, the gradient is always in the form, so y equals mx plus c. So m is always my gradient. So it's a number in front of the x. So rearranging this, so adding 4x to both sides and then dividing it by 2, okay, we get y is equal to 2 plus 4x, all divided by 2, okay, 2 divided by 2 is just 1, and then 4x divided by 2 is just 2, so y is equal to 1 plus 2x, the number in front of the x is 2, so the gradient of my line, m, is equal to 2. Okay, so it's always the number in front of the x, okay, in my straight line graph or straight line equation, y equals mx plus c. This is question number 10, guys. Find the gradient of this line. Again, rearrange it to make y the subject. So subtract 6x on both sides and then divide by 3. So 2 minus 6x, all divided by 3. Okay, so the gradient is a number in front of the x. So if I just simplify this, I get y is equal to 2/3 subtract 2x. So the number in front of the x this time is -2. Okay, so the m is equal to -2 for question number 10. Okay, so the gradient is always the value of m. So it's the coefficient of x. It's the number in front of the x. This is question number 11, guys. Okay, simplified 2x squared y times 3xy. 2 times 3 is 6. X squared times x is x cubed. And y times y is equal to y squared. Okay, so this is just simplifying indices and powers. Okay, and I forgot to actually say, guys, that question 9, 10, 11 and even 12 will appear on foundation and higher, so they can appear on both, guys. Although I would say that it is likely that question 9 and question 10, the way it's worded, is it might appear on a higher, more likely, but equation of a straight line also appears on a foundation as well. Okay, This is question number 12. Simplify 3x cubed y squared all squared. Well, I've got 3x cubed y squared times 3x cubed y squared. Okay, so remember that if something's raised to the power of 2, then it's multiplied by itself once. 3 times 3 is 9. X cubed times x cubed, I'm going to add the powers using the laws of indices. I get x to the 6, y to the power of 4, because y squared times y squared is y to the power of 4. This is question number 13. Okay, express 124 as a product of primes. So decomposing this, okay, let's just change colour. So we got so I can simplify that into 2 and 62. Okay, and I'm going to put a circle on the 2 because it's a prime number. 62 decomposes to 31 and 2. 31's a prime, 2's a prime. So my answer is 2 times 2, or 2 squared, times 31. Okay, and that is expressing 124 as a product of primes. So the word product means multiply. When it says primes, it's saying prime numbers. Okay, remember that a prime number has 2 factors only, one in itself. So 2's the only even prime number. 31 is prime because there are no other factors of 31 other than 1 and 31. Okay, this is question number 14. Express 48 as a product of primes. So decomposing this tree, 48 goes to 6 and 8. 6 and 8 decomposes further, so 6 goes to 2 and 3. Okay, and then I can circle, 2 and 3. Okay, and then 8 decomposes to 4 and 2. And then 2 and 2. Okay, sorry if it's gone a bit over. So I'm going to circle 2, 2 and 2. Okay, so I've got 4 2's there. So it's 2 times 2 times 2 times 2, which is 2 to the power of 4 times 3. Okay, so there's 1, 2, 3, 4 2's there when I decompose it, and I've got 1, 3. Okay, so that is looking at product of prime factors. Okay, and again, these would both appear on a higher and a foundation. This is question number 15. A price is reduced from £800 to £480. Calculate the percentage change. So it's a difference in the amount divided by the original, so divided by 800. So 800 minus 480, we should get is 320, if I'm not mistaken. Okay, so let's just simplify this. Okay, 332 over 80. Does it go any further? Well, I can have 16/40ths, which is going to be 8/20ths. It's going to be 4/10ths, and 4/10ths. Okay, converting that to a percentage, times it by 100, I get the answer of 40%. Okay, because 4/10ths, okay, is equivalent to 40 out of 100. Okay, which is the same as 40%. So 4/10ths is 0.4. 0.4 times 100 is 40%. Okay, this is question number 16. A price is increased from £800 to 920. Calculate the percentage change. So again, it's the difference over the original. The original this time is still going to be 800. Okay, the difference is 120. Okay, so this time I'm going to have 12 out of 80. Okay, which is 6 out of 40, which is going to be 3 out of 20. Okay, so that's going to be slightly more trickier. 3 out of 20, okay, as a percentage is actually 15%. So I'd multiply that fraction by 100 from fraction to a percentage, and I get 15%. And the reason why I know that is because 3 over 2 is 1.5. So 3 over 20 is 0.15. 0.15 times 100 is 15%. Okay. And these again would appear on a foundation and a higher, question 15 and 16. This is question number 17, guys. Okay, estimate this sum. Now, whenever you see the word estimate, you should be thinking rounding each number to one significant figure. Okay, so the nearest 10 essentially. Okay, so 43.5 is 40. 64.3 goes to 60, and 9.505 goes to 10. Okay, rounding it to one significant figure. Okay, 40 plus 60 is 100. 100 divided by 10 is 10. Okay, so that is my answer for that one. Okay, this is question number 18. Estimate 11.5 squared minus 2.09 cubed. So estimation, so round each number to one significant figure. So 11.5 goes to 10. 10 squared subtract 2 cubed. 10 squared is 100. 2 cubed is 8. 100 minus 8 is 92. Okay, so the answer for that is 92. Okay, this is question number 19. Express this number in standard form. So it's a number between 1 and 10, so it's 5.63 times 10 to the power of something. Okay, so let's just see what we can do. 1, 2, 3, 4, 5, 6, and then we get to here 7. So it's 5.63 times 10 to the 7. Okay, so standard form is always a number between 1 and 10. Okay, greater than or equal to 1 but less than 10. Okay, so it's 5.63 times 10 to the power of 7, and it's a positive 7, so my answer is going to be a big number. Okay, this is question number 20. Express this decimal in standard form. Express in standard form 0.00125. So it's 1.25 times 10, this time to the negative because it's a decimal. Okay, 1, 2, I believe. So 2, 3, sorry. So it's going to be 3 places. So 1.25 times 10 to the minus 3. And it's a minus 3 because remember the power of minus 3 means it's the reciprocal, so it's the inverse. Okay, so it's actually multiplying it by 1 over 1,000. Okay, or it's the same as dividing by 1,000. Okay, so that is looking at standard form. And again, questions 17, 18, 19, 20 will also appear on a foundation and a higher tier. But I would say that 19 and 20 would be more like foundation type questions. And yeah, and 17 and 18 would also be foundation type questions more than higher. Okay, but it's predominantly aimed at higher tier students for AQA, Edexcel and OCR. Okay, right guys, that is the end of the video. I hope it made sense. Any questions, any queries, then put it in the comment section. I'll do my best to reply and respond, okay, within the 24 hour to the first 24 to 48 hour window. Okay, if you're new to the channel, make sure you press that subscribe button. Okay, press that like button and also press that bell icon. Okay, so turn on post notifications so you don't miss out on further videos and further uploads on my channel for Key Stage 2, Key Stage 3, GCSE and A-Level Pure Maths and A-Level Further Pure Maths. Okay, and also check out my other videos on this channel. And finally, please share this video and share this channel with anyone that is wanting some extra support and help with their maths. Okay, that's it from me today, guys. Okay, thanks for watching. Okay, take care, stay safe. Okay, and I'll catch you the next one. Bye for now.